Integration. The next step for materials management is understanding system integration. For materials masters, this typically begins with an organizational master data management (MDM) system. With the foundational information that we provided in the previous material definition article, you should now have a functional understanding of your MDM environment. However, this is only the beginning. The life cycle of material data begins at object creation and extends throughout design, procurement, construction, operations, maintenance, and ultimately decommissioning. Each phase relies on seamless data flow to eliminate rework, improve visibility, and reduce lifecycle costs. Integrating design tools with material masters. Integration capabilities were minimal in the mid-90s. An organization was considered advanced if it could combine CSV files into an Access database to generate a report. Truly connected data was left up to movies and science fiction shows. Today, it is the norm. Integrated data environments are essential for realizing efficiency gains and supporting strategic objectives. In project materials management space, once materials masters are defined, they need to be passed to 3D design tools to general bills of material (BOMS). This step supports the procurement and supply chain process by organizing material needs by functional location and helping ensure on-time delivery for fabrication or construction. Here are some of the key applications that could be connected beyond the material master data, coming from an MDM. MDM 3D design tools, such as CAD platforms. Project controls, ERP, EDMS, EAM, and CMMS platforms. Product lifecycle management, PLM. Reporting dashboards and analytics tools. Types of integration. As you start to consider integration, it's important to prioritize the needs along with complexity and business value. Integration has a cost, so efforts should focus on areas where connectivity will have the greatest value. Integration really depends on the business needs and where the greatest impacts will be felt. Organizations should assess integration opportunities not just from a technical standpoint, but from a process improvement and long-term scalability perspective. To support this process, it helps to break integration planning into two categories. The first includes typical core systems used during capital projects, where accurate and timely data is critical. The second includes broader systems that come into play during later stages of the asset lifecycle, or support ongoing performance management. Number 1. Typical project integrations. 3D design tools. Project controls. EDMS, ERP. Number 2. Further considerations. EAM, CMMS, PLM. Manufacturing/construction tools. Reporting dashboards. Not all of these should be tackled at once, but starting with the end in mind and seeing the full strategy will reduce missed opportunities or concerns with connecting data. Key questions to ask. Where would integration bring the most value and why? How would I measure success against each integration type? Do I have the organization to support the type of integration I want? Integration requirements. Establishing integration requires clear objectives, an understanding of your current systems and processes, and a well-planned architecture. In many cases, middleware or an integration platform is needed to facilitate communication between systems. Suggested best practices. Clearly define the integration scope and align it with business goals. Map inputs and outputs across systems to avoid gaps. Evaluate middleware or integration platforms for scalable, reusable connections. Key questions to ask. What data needs to be shared across systems? What standards and protocols will be used for integration? How will integration performance and reliability be monitored? Data ownership and RACI. Data ownership is a critical aspect of integrating design tools within industrial engineering companies. It ensures that there is clear accountability for the data, which is essential for maintaining data, integrity, and security. When data ownership is well defined, it helps establish who is responsible for ensuring data accuracy, updates, and compliance with regulatory requirements. It also plays a key role in identifying and maintaining a clear source of truth for data across systems, ensuring that all stakeholders are working from the same validated information. This clarity prevents confusion and ensures that data management processes are streamlined and efficient. Moreover, data ownership fosters a sense of responsibility among stakeholders, encouraging them to take proactive measures to protect and maintain the quality of the data. Developing a RACI matrix is equally important in the context of integration. A RACI matrix clearly outlines the roles and responsibilities of all stakeholders involved in the integration process. It helps in identifying who is responsible for specific tasks, who is accountable for overall success, who needs to be consulted for their expertise, and who should be kept informed about progress and decisions. This structured approach ensures that everyone knows their role and reduces the risk of miscommunication and overlapping duties. By establishing a RACI matrix, organizations can manage the integration process more effectively so that all aspects are covered and the transition is smooth and efficient. Key questions to ask. Is there an existing data organization within your organization to provide overall governance? Who will be the data owners and what are their responsibilities? How will changes be managed within the data organization? Data synchronization. Data synchronization is vital to integrating design or operational systems because it ensures consistency across all systems, tools, and processes. When data is synchronized, all stakeholders have access to the same up-to-date information, which significantly reduces errors and discrepancies. Synchronization streamlines workflows by automating data updates, saving time and reducing the need for manual intervention. This efficiency not only enhances productivity, but also allows engineers and operators to focus on more critical tasks rather than data management. Additionally, data synchronization facilitates better collaboration within teams. When everyone has real-time access to the same data, it improves communication and coordination, leading to more effective teamwork. This is particularly important between the different stages of projects, including engineering, procurement, and construction, into operations involving multiple stakeholders and complex processes. Lastly, data synchronization helps in maintaining regulatory compliance by ensuring that data is consistently updated and accurate across all systems, which is crucial for meeting industry-specific regulations and standards, as well as enabling quicker maintenance, planned changes, or plant upgrades. Key questions to ask. What are your primary data sources? What systems are currently in use, and are there specific security protocols to consider? What is the volume, and how frequently does your data change and need to be synchronized? Change management and scalability. Information is rarely static. It will continue to evolve as it flows throughout the process and along its data chain. Understanding how that data will change and around the specific processes of change is important when defining integration. Scalability is another critical factor. As your organization grows or adopts new tools and processes, your integration architecture must be able to accommodate additional data volume, formats, and workflows. Anticipating these needs upfront helps avoid costly redesigns later. Key questions to ask. How will architecture accommodate future growth, and what are the scalability requirements? How will data change throughout the process? Does it get overwritten, augmented, or are historical records required for data comparison? What flexibility is needed to adapt to changing business needs? Putting the pieces together. All the above components go into a well-designed integration landscape. Cost savings, typically in a properly designed integration deployment, can be seen in the following areas. System design. Understanding integration requirements is important, as it helps prevent costly design issues such as overdesign, increased complexity, or data being unavailable at the right time or in the right tools to meet business demands. Ignoring these considerations can result in higher costs, lower user adoption, implementation delays, and operational disruptions. Collaboration/alignment and stakeholder engagement. Integration is about intertwining data from multiple sources. This is often disruptive to existing ways of working and overall resource comfort levels. Telling people that this will be better is not a recipe for success. To promote trust in the new path, this has to be built with early collaboration and feedback, alignment between stakeholders and early adoption, sufficient resource involvement, and buy-in from key users. Data quality. Ensuring proper data quality through well-mapped business processes, validation and cleansing helps mitigate migration issues and reduce data mistrust. Providing adequate time for training and testing further improves data quality and confirms that data has been correctly structured and mapped. Lessons from the field. When integration is not approached with careful planning and alignment across system design, stakeholder engagement, and data quality, the consequences can be significant. In some cases, project budgets have increased by as much as 25% due to rework, poor adoption, or data issues. One high-profile example is Nike's ERP and supply chain integration project, which encountered major delays and cost overruns due to challenges in system alignment and readiness. For a deeper look at how integration missteps can impact business outcomes, see the full case study here. Thinking about the future. Integration continually evolves. New integrations will become available, different methods for integration are developed, and business needs change. Having a regular review cycle, a minimum of every 3 years, should be established. This doesn't mean you need to change every 3 years, but understanding what changes are available, coming, and required will enable a company to be reactive and responsive to new business demands. As part of that forward-looking approach, it's also wise to seek out external expertise and leverage lessons learned. Benefiting from challenges and experiences from others can provide you with an expedited pathway to success. Although not every company's journey is the same, there are often common threads. Not repeating known pitfalls can sometimes have significant cost savings and also provide valuable insight into other opportunities or faster deployment. ReVisionz brings a structured yet flexible approach to integration planning that's grounded in real-world project experience and deep technical knowledge. We help organizations define scalable integration architectures, clarify system roles, and align long-term priorities across digital projects and operations environments. This allows clients to move with purpose, avoid missteps, and build integrations that remain resilient as tools, teams, and business requirements evolve, ultimately accelerating return on their digital investments. To follow the rest of the ReVisionz series on materials management, subscribe to our Digital Journey Notebook. You can also connect with us directly for a personalized approach that fits your organization's needs.